This is SpaceTime Series 24, Episode 68. Coming up on SpaceTime, the Rosetta Stone eruption which could help explain solar explosions, Juno's close encounter with the Jovian moon Ganymede, and Sierra Nevada's Dream Chaser spaceplane delayed until next year. All that and more coming up on SpaceTime.
Welcome to SpaceTime with Stuart Gary.
A dramatic multi-staged eruption on the Sun has revealed new clues that could help scientists solve the long-standing mystery of what causes the Sun's powerful and unpredictable explosions. A report in the astrophysical journal Letters claims uncovering this fundamental physics could help scientists better predict the eruptions which cause dangerous space weather events on Earth. The explosion contained components of three different types of solar eruptions that usually occur separately, making it the first time such an event has been observed. Having all three eruption types together in the one event provides scientists with something of a sort of solar version of the Rosetta Stone, allowing them to translate what they know about each type of solar eruption in order to better understand the other types of eruptions, in the process uncovering the underlying mechanism which could help explain all types of solar eruptions. The study's lead author Emily Mason from NASA's Goddard Space Flight Center in Greenbelt, Maryland, says the event drives home the point that these eruptions are caused by the same mechanism, simply on different scales. Eruptions on the Sun usually come in one of three forms: a coronal mass ejection or CME, a jet, or a partial eruption. Coronal mass ejections and jets are both explosive eruptions, casting energy and particles into space. But they each look very different. Jets erupt as narrow columns of solar material, while coronal mass ejections or CME form huge bubbles that expand out, pushed and sculptured by the Sun's magnetic fields. Partial eruptions, on the other hand, start erupting from the surface but don't develop enough energy to leave the Sun, so most of the material falls back down onto the solar surface. This Rosetta Stone eruption occurred back on March the 12th and 13th in 2016. It was observed by NASA's Solar Dynamics Observatory spacecraft, as well as the joint NASA and European Space Agency Solar and Heliospheric Observatory spacecraft SOHO. What scientists saw was the ejection of a hot layer of solar material above a magnetically active region on the Sun's surface. The event was too big to be a jet, but also too narrow to be a coronal mass ejection. Within half an hour, a second cooler layer of material on the Sun's surface also started to erupt from the same place. But ultimately, it collapsed back down as a partial eruption. Seeing an eruption with both jet and coronal mass ejection characteristics tells scientists they are likely caused by the same mechanism. And the observations allow scientists to apply what they already know about jets to coronal mass ejections. The event also tells scientists that partial eruptions occur on the same spectrum, but encounter some as yet unknown limiter which restricts their energy, preventing them from making it off the solar surface. Understanding the mechanism behind these events, especially coronal mass ejections, are of critical importance for predicting when a large solar eruption might cause disruptions here on Earth. See, coronal mass ejections can spew out massive clouds of high-energy charged particles and magnetic fields. These will stream out across the solar system, and if the Earth just happens to be in the way at the time of one of these space weather events, it'll cause a geomagnetic storm. When these solar storms reach the Earth, the flux of ionized particles slams into the planet's magnetosphere. The highly charged particles can damage or destroy spacecraft, shorting out electronics and frying circuits. They also cause the atmosphere to physically expand and contract. That increases atmospheric drag on orbiting spacecraft, resulting in premature orbital decay and the need to use up more fuel in order to maintain an operational orbit. Space weather events also increase the level of radiation exposure astronauts can experience, thereby affecting their health. And down on the ground, these solar storms can overload power lines, destroying transformers and causing widespread blackouts. Space weather events also affect communications and navigation systems, and so it forces polar airline flights to be rerouted to lower latitudes, in the process using up more fuel. By modelling the new Rosetta Eruption and others like it, scientists hope to figure out what causes solar eruptions and determine their characteristics. Finding a trigger would ultimately allow scientists to predict when large-scale eruptions could threaten the Earth several hours in advance, providing enough time for astronauts and spacecraft operators to take precautionary measures. This report from NASA TV.
An unusual eruption on the Sun may offer clues to understanding our star's mysterious explosions. Solar eruptions are massive releases of material off the surface of the Sun. This material can travel across the solar system, to Earth and Mars. The radiation and the material from the Sun can interact with the planet's magnetic fields, affecting astronauts and technology. Eruptions on the Sun usually come in one of three forms: coronal mass ejections, jets, and partial eruptions. The new research studied an event named the Rosetta Stone of solar eruptions. Just as the Rosetta Stone was the key to understanding Egyptian hieroglyphics, studying this eruption could be the key to understanding all types of solar eruptions. In the Rosetta Stone eruption, all three types of eruptions happened in the same event. They usually occur separately. The main eruption was too big to be a jet, but too narrow to be a coronal mass ejection. A second cooler layer of material on the surface of the Sun also started to erupt about a half an hour later, but it fell back down as a partial solar eruption. This Rosetta Stone of solar eruptions will also give clues to help scientists predict large eruptions in the future. The better our predictions are, the more time we have to prepare for material from the Sun to interact with Earth's magnetic field. Predicting large solar eruptions can help better protect our astronauts and technology, near Earth and beyond.
This is SpaceTime. Still to come, NASA's Juno spacecraft undertakes a close encounter with the Jovian moon Ganymede. And Sierra Nevada's Dream Chaser spaceplane, which was slated to begin flying supply missions to the International Space Station this year, will now not begin operations until sometime in 2022. All that and more still to come on SpaceTime. NASA's Juno spacecraft has undertaken a close encounter with the Jovian moon Ganymede. With a diameter of 5,268 kilometres, Ganymede is the largest moon in the solar system and 26% larger by volume than the planet Mercury. Juno raced past Ganymede at almost 19 kilometres per second as it travelled towards its 33rd science pass of Jupiter, screaming low over the Jovian cloud tops at some 58 kilometres per second. Juno's flight path brought it to within 1,038 kilometres of Ganymede's surface. It was the closest encounter since NASA's Galileo spacecraft made its penultimate close approach back on May the 20th in the year 2000. Along with striking imagery, the solar-powered spacecraft's flyby has yielded fresh insights into the moon's composition, its ionosphere, magnetosphere, and its icy shell. Juno's measurements of the radiation environment near the moon will also benefit future missions to the Jovian system. Ganymede is the only moon in the solar system with its own magnetosphere, a bubble-shaped region of charged particles surrounding the celestial body. Juno's advanced suite of scientific instruments allowed it to study Ganymede in ways never before possible. Juno's principal investigator, Scott Bolton, from the Southwest Research Institute in San Antonio, Texas, says by flying so close, science's understanding of Ganymede is brought into the 21st century, both complementing future missions and helping prepare for the next generation of missions to the Jovian system, namely NASA's Europa Clipper and ESA's JUICE mission. Juno's science instruments began collecting data 3 hours before the spacecraft's closest approach. Along with the ultraviolet spectrograph and Jovian infrared auroral mapper, Juno's microwave radiometer peered down onto Ganymede's water ice crust, obtaining data on its composition and temperature. See, Ganymede's ice shell has both light and dark regions, suggesting that some areas may be pure water ice, while others contain dirty ice. Juno is studying how the composition and structure of the ice varies with depth, leading to a better understanding of how the ice shell forms and the ongoing processes which resurface the ice over time. Meanwhile, Juno's X and Ka band radios undertook radio occultation experiments during the flyby, probing the moon's tenuous ionosphere, where gases are excited by solar radiation to form ions. As Juno passed behind Ganymede, radio signals travelled through Ganymede's ionosphere, causing small changes in frequency. And these were picked up by two antennas at NASA's Deep Space Communications complex at Tidbinbilla near Canberra. The data will help scientists better understand the connection between Ganymede's ionosphere, its intrinsic magnetic field, and Jupiter's magnetosphere. Meanwhile, Juno's Stellar Reference Unit navigation camera, which is shielded against radiation which could otherwise adversely affect it, gathered information on the high-energy radiation environment around Ganymede. At the same time, its advanced stellar compass camera counted energetic electrons that penetrated its shielding. Finally, the Juno Cam imager collected a series of stunning images of the giant moon during the flyby. Juno science team will now scour these images, comparing them to those previously taken by the Voyager and Galileo missions. They'll be looking for changes in surface features that might have occurred over the past 4+ decades. For example, any changes to crater distribution on the surface would help astronomers better understand the current population of objects which could impact the moons of the outer solar system. Juno was launched back on August 5, 2011 from the Cape Canaveral Air Force Station in Florida. The Lockheed Martin-built spacecraft is designed to study the chemical composition of Jupiter's immense atmosphere and cloud structure, peering deep below the obscuring cloud tops to probe convection currents and thermal engines driving its circulation patterns and spectacular surface weather features, its cyclonic storms, and its iconic salmon and cream-coloured atmospheric bands. Juno is also measuring Jupiter's gravity field to better understand the internal structure of the solar system's largest planet, as well as its magnetic field, its polar magnetosphere, and its auroral activity. Jupiter contains more mass than the rest of the solar system combined, other than the Sun. So by better understanding how the Jovian gas giant formed, scientists will learn more about the formation of the rest of the solar system as well. The 3,625 kilogram spacecraft achieved Jovian orbit insertion on July 5, 2016. Juno was placed into a highly elongated polar orbit, designed to avoid as much of Jupiter's damaging radiation belts as possible. This allows the spacecraft to swoop down and skim just 3,400 kilometers above the swirling Jovian cloud tops, before being taken back out again to more than 8.1 million kilometers. To further protect the spacecraft from Jupiter's deadly radiation, Juno's most delicate instruments and control systems are housed in a specially shielded strongbox. Original plans called for 37 orbits around the 143,000 kilometre wide planet, with the original 53.4 Earth day polar orbits eventually contracting down to just 14 Earth days. However, those plans were scrapped following concerns about the spacecraft's main engine, meaning that all orbits would remain at 53.4 Earth days, which would have meant fewer overall orbits. The good news is that Juno has coped with Jupiter's extreme radiation belts better than expected, allowing a mission extension to proceed. And by extending the mission, those missing orbits can now be included. This is SpaceTime. Still to come, Sierra Nevada's Dream Chaser spaceplane, which was to begin supply missions to the space station in September, will now not begin operations till sometime next year. And OneWeb's planned mega constellation gets another 36 satellites. All that and more still to come on SpaceTime. Sierra Nevada's Dream Chaser spaceplane, which was slated to begin supply missions to the International Space Station in September this year, will now not begin operations until sometime in 2022. Sierra Nevada are blaming the delay on COVID-19 pandemic-related issues, saying restrictions have prevented engineers from being on site for structural testing of the spacecraft's new cargo module. The winged lifting body spacecraft has been contracted by NASA to undertake at least 6 cargo flights to the orbiting outpost, as well as an orbital mission for the United Nations in 2024. Dream Chaser will launch vertically aboard the United Launch Alliance's new Vulcan Centaur rocket from Space Launch Complex 41 at the Cape Canaveral Space Force Station in Florida, docking with the space station's Harmony module. Each 10-metre-long Dream Chaser spacecraft will carry 5 tons of cargo. Attached to the rear of the spaceplane will be a 5-metre-long pressurised cargo module extension called Shooting Star, and it will carry an additional 4.5 tonnes of supplies. Dream Chaser will return to Earth, landing conventionally on the Kennedy Space Center's Space Shuttle runway, carrying up to 1,750 kilograms of returned experiments and equipment. The more gentle runway landing will allow Dream Chaser to return to Earth more delicate equipment and experiments, things that will be damaged in a rougher high-G capsule splashdown using Dragon. Sierra Nevada is still searching for a suitable processing facility at the Cape to turn around and service the reusable spaceplane between flights. Under the new schedule, the first Dream Chaser, named Tenacity, will be prepared for delivery to the Space Center in about a year from now. A second Dream Chaser is currently under construction. A third Dream Chaser was built as an engineering demonstrator for ground and flight verification and validation tests. Each Dream Chaser will be capable of flying at least 15 missions over a 10-year lifespan. The spacecraft was originally designed to transport up to 7 people on crew transfer missions to the space station, but it lost out to SpaceX's Dragon and the troubled Boeing CST-100 Starliner in NASA's commercial crew transport contracts. SpaceX began flying astronauts on Dragon to the space station in 2019, and Boeing hopes to get its first crew up there before the end of this year. As a sort of, consolation prize, NASA awarded Dream Chaser a space station commercial resupply program contract alongside the existing SpaceX Dragon and orbital, now Northrop Grumman, Cygnus cargo ships. Sierra Nevada also hopes to use Dream Chaser to launch and build its own orbiting habitat in space, sometime before NASA retires the International Space Station around 2028. The Dream Chaser lifting body design goes back over 60 years, with its origins in the United States Air Force 1957 X-20 Dinosaur spacecraft, which was to be launched on top of a modified Titan III rocket before the US government decided to put NASA in charge of its manned spaceflight program. NASA continued its development throughout the 1960s and early 70s with a range of experimental spacecraft, including the Northrop Grumman M2, the Martin X-23 Prime, the Martin Marietta X-24, and the Northrop HL-10. During the 1990s, NASA used the same basic design to develop the HL-20 experimental spaceplane, which would eventually evolve into the X-38 emergency crew return vehicle. The X-38 was designed to be an emergency escape pod transported to the International Space Station in the payload bay of the Space Shuttle. There it would remain docked to the orbiting outpost until needed. However, the project was cancelled in 2002 following budget cuts. Meanwhile, the Pentagon is now looking at using the Shooting Star cargo module as the basis for an autonomous unmanned military space station for research and development, training and operational missions in low Earth orbit. Sierra Nevada will redesign the module to include guidance, navigation and control systems for sustained free-flight operations. It would host specialized payloads, undertake experimental testing, manufacturing and assembly in microgravity, and carry a range of logistics, whatever that means. Longer-term plans could see higher elliptical and geosynchronous Earth orbits, as well as more distant lunar orbits. This is SpaceTime. Still to come, OneWeb's planned mega constellation gets another 36 satellites. And later in the science report, planet Earth looks set to breach 1.5 degrees Celsius warming within the next 5 years. All that and more still to come on SpaceTime. Despite the growing concerns of scientists, a Russian Soyuz rocket has successfully placed another 36 British OneWeb internet broadband telecommunications satellites into low Earth orbit. The mission aboard a Soyuz 21A rocket from the Vostochny Cosmodrome in Russia's Far East is another step in OneWeb's plans for a mega satellite constellation to rival SpaceX's highly criticized Starlink constellation, which is already damaging important astronomical research efforts. It follows 2 previous OneWeb launches of 36 satellites each by Roscosmos in April and March. Arianespace is contracted to make 16 Soyuz launches between December 2020 and the end of 2022 in order to get those spacecraft into orbit. The launch on behalf of Arianespace had been delayed by a day because of technical issues. OneWeb satellites are all launched in clusters of 36 before separating out when in orbit. The company is planning an initial constellation of some 650 of the 150-kilogram Ku-band spacecraft. OneWeb had applied to ultimately fly some 47,844 satellites. But after going through bankruptcy, they shaved that down to 6,372, at least for now. Russia's Vostochny Cosmodrome is being developed to ultimately replace the Baikonur Cosmodrome, which Moscow currently rents from Kazakhstan. However, the project's been consistently behind schedule, with construction marred by controversies and corruption. This is SpaceTime. And time now to take another brief look at some of the other stories making news in science this week with the Science Report. The World Meteorological Organization and Britain's Met Office have issued a joint warning that the Earth will breach the 1.5 Celsius warming mark within the next 5 years. The alarming warning is contained in the new updated Global 10-Year Climate Prediction Report, which is based on an updated assessment of global climate trends. It shows a 40% chance of the annual average global temperature surpassing 1.5 degrees Celsius above pre-industrial temperatures, the aspirational warming limit of the Paris Climate Accord. And there's a 90% chance of at least 1 year between 2021 and 2025 of being the hottest year ever recorded. The annual average global temperature over the next 5 years will be at least 1 degree Celsius warmer than pre-industrial levels, with a range of between 0.9 and 1.8 degrees Celsius warmer. Increasing temperatures means more melting ice, higher sea levels, more heatwave and other extreme weather conditions, and greater impacts on food security, health, the environment and sustainable development. The landmark 2015 Paris Climate Deal saw nations commit to limit global temperature increases to below 2 degrees Celsius above pre-industrial levels. However, under the deal, China and India have been allowed to increase their emissions without any restrictions for at least another 10 years, with China's annual carbon dioxide increase alone being greater than Australia's total annual carbon dioxide output. A new study has shown that taking extra vitamin D won't help protect you from the COVID-19 coronavirus. The authors analysed the DNA of 4,134 people with COVID-19 and 1,284,876 people without COVID-19 in order to determine whether a genetic predisposition for higher vitamin D levels was associated with a less severe disease outcome in people with COVID-19. The findings, reported in the journal PLOS Medicine, showed no evidence of an association between genetically predicted vitamin D levels and COVID-19 susceptibility, hospitalization, or severe disease, suggesting that raising circulating vitamin D levels through supplementation won't improve COVID-19 outcomes in the general population. However, the authors cautioned they did not include any participants with vitamin D deficiencies, who they say may benefit from vitamin D supplementation. The World Health Organization now estimates some 8 million people have been killed by the COVID-19 coronavirus, with over 3.8 million confirmed fatalities and more than 176 million people infected since the deadly disease first spread out of Wuhan, China. The first ever complete egg from what was Australia's smallest emu has been found in a sand dune on King Island. The discovery, reported in the journal Biology Letters, sheds new light on what was Australia's smallest emu. It was discovered by a local islander and comes from the King Island emu, which has been extinct for nearly 100 years. While the egg was about the same size as those laid by mainland emus, researchers used the egg to calculate the King Island emu was about 44% smaller than the mainland birds we see today. A report in the Wall Street Journal warns that Google is allowing other people to read your private emails. The search engine giant has been allowing third-party developers to access your personal Gmail accounts on the pretext of improving your service. Google insists that no one reads your Gmail unless you've given them specific permission by agreeing to their conditions. You know, those 50 pages of fine print which simply ask you to click I agree at the bottom? The practice of sharing user private data became common knowledge after it was revealed that Facebook allowed their third-party apps to harvest their user data. However, Google says it doesn't do this anymore, but it admits there are still exceptions, such as things they determine to be security issues or problems with the system, although they won't go into details about what that actually means. Google says it's also pledged to stop scanning your emails on Gmail to personalize ads. The news comes as Google were forced to reassign their global lead of diversity strategy and research, Kamau Bob, to another job because of racist comments he made on a blog post. A Google spokesperson condemned the bigoted comments made by Kamau Bob and acknowledged that the comments had caused deep offence and pain, but still, Google didn't sack him. Now, staying with tech, and Apple has announced their new iOS 15 operating system. For the details, we're joined by technology editor Alex Zaharov-Reutt from ITWire.com.
Apple held its worldwide developer conference where they showed new operating systems for the iPhone, iPad, Mac, the Apple Watch, and Apple TV. And just some of the headline features for iOS 15, which is also in iPadOS 15, you can now share your FaceTime movies and music with other people. So you can be watching the same TV show on Disney or Apple TV, and everybody that's on FaceTime can watch at the same time. And in fact, you can even share FaceTime links with people on Androids and on Windows devices through a web link. They can click a button, it opens up in a browser, and has the same encryption. In the US, people will be able to put their driver's license into their Apple Wallet, starting with certain states. And also you can now use the iPhone to unlock keys and to unlock locks in your home and at work, if obviously you have the newest devices that can do that. So Apple's trying to replace your wallet completely. There's other new iMessage features that let you share photos in a much easier or better way so that you can share collections and have new emojis. You can also now identify animals, items, and plants in photos, a bit like Google's Lens. Very handy. You know, if you ever watch that movie Avatar and they're holding a transparent tablet and seeing what the plant is, well, you've been able to do that for some time with Google Lens, but now it's being built in to iOS as standard. You can also block out notifications and messages at certain times with a new focus thing. The old Nokias used to be able to have a different ringtone for when you were at work and for when you're at home. And people used to say to me, I remember, why can't I do this on an iPhone? Well, now you can as of iOS 15. You can also translate, copy, and interact with text in photos. So if you've got a photo that's got a whiteboard, or you've got some text in there, or the phone number of a restaurant, you can actually just hit a button and then you can select that text as though it was in your notes and tap on a phone number and make it call. You can also create legacy contacts so that if you need help getting back into your phone, or if you have passed away sadly, you can actually have people being able to get your photos and other information after you've passed on. You can also use AirPods as a type of hearing aid, so there'll be a new feature where the AirPods Pro can really tune into conversations, or you can have it so that it can listen to everything. And look, there's plenty of other apps and features and updates. iPad multitasking is improved. If you have macOS 12 Monterey and you have an iPad there, you can actually use the trackpad on your mouse and your keyboard and move the mouse across from the edge of the Mac screen onto the iPad screen. And so, it's really cool how all of these things are possible. Developer versions of the operating systems are out now. Beta versions will be available in July. It'll come out in the US fall, which is the Australian spring. People who are wary of updates might wish to wait for 15.1, for example, which might take another month or something after that. But I'll be testing one of the developer betas on different devices. Well, not on my primary devices, just to see what it's like. But, go to youtube.com/Apple, look for the WWDC21 keynote. It's an hour and 46 minutes, but it's fantastic. There's so much they unveiled, including spatial audio.
New security features for apps too, so you know what the app's doing on your phone to you.
Yeah, even things like iCloud Plus, which has got private relay. It won't work in China and some other countries, but it's basically like having a VPN, except Apple sends what you're surfing for through one of their servers, and then it sends it through a different server. And those two servers don't know what the other one, who the other one, one server knows what's being served and the other server is sending it through, but both servers are not able to see what the other server is doing, so they can never identify you. And Apple says that it's going to happen with great speed and that you won't notice any sort of slowdown. So we're yet to see how that works, but it's exciting stuff.
That's Alex Zaharov-Reutt from ITWire.com. And that's the show for now. SpaceTime is available every Monday, Wednesday and Friday through Apple Podcasts, iTunes, Stitcher, Google Podcast, Pocket Casts, Spotify, Acast, Amazon Music, Bytes.com, SoundCloud, YouTube, your favourite podcast download provider, and from spacetimewithstuartgary.com. SpaceTime's also broadcast through the National Science Foundation on Science Zone Radio and on both iHeartRadio and TuneIn Radio. And you can help to support our show by visiting the SpaceTime store for a range of promotional merchandising goodies, or by becoming a SpaceTime patron, which gives you access to triple-episode commercial-free versions of the show, as well as lots of bonus audio content which doesn't go to air, access to our exclusive Facebook group, and other rewards. Just go to spacetimewithstuartgary.com for full details. And if you want more SpaceTime, please check out our blog, where you'll find all the stuff we couldn't fit in the show, as well as heaps of images, news stories, loads of videos, and things on the web I find interesting or amusing. Just go to spacetimewithstuartgary.tumblr.com. That's all one word, and that's Tumblr without the E. You can also follow us through @StuartGary on Twitter, @SpaceTimeWithStuartGary on Instagram, through our SpaceTime YouTube channel, and on Facebook, just go to facebook.com/SpaceTime with Stuart Gary. And SpaceTime is brought to you in collaboration with Australian Sky and Telescope magazine, your window on the universe.
You've been listening to SpaceTime with Stuart Gary. This has been another quality podcast production from Bytes.com.